Good morning, good evening, wherever you are, and welcome to episode 83 of the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And before we get started, I want to do a couple of quick housekeeping things for all the regular listeners. First off, Aaron is still in Portland tonight. He's coming back from the OpenStack Summit, so lots of good stuff that he's gathered. We've been talking all week, so he's going to have a couple of shows that will come out of the OpenStack Summit for people that are interested in that. The second thing is, for anybody that hasn't noticed, we fired up a new podcast called The Mobilecast, and it seems to be getting a lot of traction. People seem to like it. So if you're interested in anything having to do with mobile computing, mobile devices, mobile lifestyles, tune into that. It's being hosted by Brian Katz. He's doing a really, really good job. So enough of that. Let's get to the show. So one of the things that we've heard from a lot of our listeners and we've seen in the marketplace is this idea of hybrid cloud as a concept. And for a number of years, we've heard over and over again from CIOs and from the industry that people want this concept of sort of the best of public and the best of private. They want, security, but they want flexibility. And hybrid cloud has struggled a little bit in the last couple of years. It's been very theoretical, but people have struggled to really make it work. And tonight, we're pretty excited. So we've been looking for companies and people that are doing interesting things around cloud computing, and especially around hybrid cloud. And so tonight, we're really excited to have Rajeev Chawla, who's CEO of a new company called CloudVelocity, on with us tonight. Rajeev, thanks so much for coming on.
My pleasure. Thank you.
So first and foremost, CloudVelocity is a new company, but this is not your first startup. So tell us a little bit about your background, what you were doing prior to CloudVelocity, and kind of what's getting you excited about this segment of the market.
Sure, be happy to. So yes, I've been involved with a couple of other startups prior to founding CloudVelocity. Prior to CloudVelocity, I co-founded a company called Neopath Networks back in 2002 or so, and it was acquired by Cisco. At Neopath, we virtualize network access file protocols, NFS and CIFS, to allow you to combine capacity and performance coming from heterogeneous file servers such as NetApp and EMC and present a single namespace to the clients. And after that company was acquired by Cisco, I spent some time at Cisco and then joined the Mayfield Fund as an EIR, and started exploring some ideas and technologies that were at the center stage of this new era of computing. A lot of people are calling it cloud computing, but we'll get into the specifics of what that is. And my co-founders from Neopath joined me, and we started this journey together again. In December of 2010, we launched a company in stealth mode, and last December, we came out of stealth mode, and what we are known as is CloudVelocity today.
Okay. Very good. So Greg Ness, who's your sort of chief marketing officer, runs marketing, is somebody that we've known for a while. We've had a tremendous respect for him in terms of his market acumen and his technology knowledge. So he turned us on to you guys. So let's talk about. First and foremost, let's talk about CloudVelocity. What do you guys do? What's your take on sort of the technology challenge of hybrid cloud?
Sure. Before I talk about what we do, I think what would be helpful is to explain what the problem statement is and why we decided to actually go and try to address this issue.
Absolutely.
To us, the problem statement is pretty straightforward. If you look at the enterprises, they made significant investments in their infrastructure and applications. They're not just going to throw it away.
Right.
But the ugly side is that there's always these never-ending demands on the IT to provide more and more resources to meet new needs.
Okay.
Well, so no matter what you do inside the enterprise, you're always going to be finite resources. And there's always going to be new demands and the need to get more resources. And then there's a new thing happening in the industry, which is you got these public clouds such as Amazon, AWS, Microsoft Azure, and so on, seemingly full of infinite resources. So when we looked at this problem where you got resources inside your enterprise, whether it be data center or colo or hosting, And then we looked at these resources which were sitting in these public clouds. They were islands of resources. So when we looked at this and we realized, this was something which needed to get addressed because, our view is that you have to be able to treat this as a dynamic pool of resources. And this is what we set out to solve.
Okay.
And so what we've done at CloudVelocity is essentially built software that makes these public clouds such as Amazon AWS or Microsoft Azure a seamless extension of the enterprise data center. And that's not where the story ends. Ultimately, these resources are where you want to run your applications. So the part of the software then enables these existing applications, not just new. There's a lot of talk about, being able to run new applications in these cloud environments. So the approach we took was, look at these enterprises. This is not just net new applications. They have a huge investment of existing applications. So you want to be able to take these existing applications and run them with no modification as is in these public cloud environments. So in a nutshell, the software makes public clouds a seamless extension of the data center and then makes these applications run as is.
Okay.
And the beauty of the solution, so Brian, the beauty of the solution is, you might think about, okay, I might take an application which runs today inside my data center and then move this workload into, let's say, AWS. Well, but you know what? This application may be accessing an LDAP server, which is shared among other applications which are still running inside your data center. So the beauty of our solution is that you could take this new workload, run it in AWS, but still have it access the LDAP server, which is sitting inside your data center. And this is the genesis of hybrid cloud. So the whole notion is the resources coming from what you own, whether it be your data center, colo, or hosting, as well as the resources coming from public clouds. And there's a combination of these resources to be deployed in such a way that it gives you increased agility, protection, and scale. And that's what we're offering.
Okay. So let's talk a little bit about how that works. And we don't have to go super deep as much as you feel comfortable. So in that case, in essence what you're saying is there's got to be a way to encapsulate an existing application. So understand that application, encapsulate it, somehow move it to the public cloud, whether it's, like you said, Azure or Rackspace or Amazon Web Services. But then you've also got to be able to build the network connectivity or security associations, authentication back into the enterprise so that you can talk to an LDAP server or an AD server or some other sort of server. How do you guys go about doing that? What's sort of the onboarding process, if you will, for an existing application, content management or a Microsoft application or something? How would that onboarding process work?
That's a great question. So some of this is part of our secret sauce, but
okay.
What I can tell you is at the core of this, I think you captured it very right. You want to be able to encapsulate application, and when you look at an application, when I use the word application, I'm not just referring to the application stack, because application is also dependent on services offered by the operating system, may depend on the libraries and other binaries which reside on the system.
Sure.
Right? So when we say application, we mean the entire system, not just the application stack. So being able to have an application which runs inside your data center and being able to run that in a cloud side, the first thing you need to do is figure out, these days applications are no longer running on just single host. When I say, I've got a web application, well, typically it's made up of multiple machines. These group of machines is what makes up the application.
Right.
Could be, yeah, exactly. So it could be a bunch of, number of web servers, app servers, database servers. You have to first be able to go and figure out, what constitutes this application. Then once you have a sense of, okay, let's say we got these 10 servers, 5 of them are web servers, 3 app servers, and 2 database servers, for example. If that's what makes up the application, when you say, now this app has to run in a cloud site, whether it be AWS or Azure, well, these 10 systems have to run there because that's what makes up the application, right? So the part of our software, first thing it does is think of this as trying to go discover what makes up the application, figure out what network services it's dependent on, because like we talked about LDAP or Active Directory, look at, does it have any NFS mount points, or in other words, does it depend on any data which is coming from file servers, network file servers? Then once you do that, then you want to go and blueprint these systems to get a sense of what kind of CPU, memory, networking, storage configurations are on these machines. Because you want to be able to go and provision very similar systems. Of course, you won't be able to get exactly the same because you're at the mercy of the cloud service provider.
Sure.
In terms of you can get a small or a large. I'm sure you're familiar with the approach which cloud service providers take. You can't go and tell them I want 2.4 gigahertz processor-based system. It's typically boils down to some categories.
Right, sure.
Right. So once you have that, then so once you've blueprinted these machines, you want to go and figure out, okay, can I get a similar set of systems in the cloud side where I can go and run the application? Then you go do this. Then this is now the part of the secret sauce which comes in. So we've developed a core piece of technology which continuously replicates and synchronizes your application. And when I say application, this is the operating system, the libraries, the binaries, the app software stack, and any corresponding application data which might be sitting on local disk, on a SAN, or coming from a file server. So we continuously replicate and synchronize all of this into disk volumes which are sitting in a cloud site, which is part of our service. So you don't have to have any instances running inside the cloud site to be able to do this. And once you have this consistent point inside the cloud site where you've been able to replicate and synchronize, and remember, we had created a blueprint before, we can now go and launch instances mapping to that blueprint and taking the OS and the config and the application data and the application software stacks from the things which we were synchronizing on, slap them on the instances which we get from the cloud vendor, and essentially run the application. So now you got a clone, an exact replica of your application, which was running in the data center, also running in the cloud side, right?
Okay. So let me stop you there for a second, because it's an interesting thing, and I want to make sure I'm not kind of shooting over this. No. It was a very good. Yeah, but so let me see. I want to make sure I understand something right. So if I'm a customer, I have an application that's running today. So it's running in production or it's running in test, whatever environment it's running. In essence, you guys do what a lot of the kind of the backup companies do today, where you're doing live replication, so sort of mount point, synchronized replication, similar to like what EMC does with a vPlex technology or Zertos does, so you're doing that off to the cloud while the application's still running, right? You don't shut the application down up front, and then at some point you've got what looks like in essence like a something running in sync, and you could turn the one off in your data center and turn the other one on, and all you're going to do is probably move a load balancing. Is that sound right? I mean, is that sort of what it does?
Right. But I have to say I'm really pleased to see how you try to draw similarities between the backup vendors and what we do. So it's not quite the way you expressed it,
okay.
Because first of all, to be able to run an operating system, let's say you're running some version of Linux with patches installed on your system, in your data center. Well, typically on a cloud side, what you have is templates coming from the cloud service vendor where you can go and run the OS what the cloud provider gives you. Mm-hmm. What we've done is so this is where a lot of differences are. So when we talk about replication and synchronization, there's a lot of transformation going on when you launch instances. It's not just the same environment, exactly the same environment, because that's not going to be able to run in the cloud side. So for very simple examples, you may have to inject some drivers. You may have to remove some drivers.
Okay.
You would have to go and change the config files in the operating system so that the machine comes up thinking it's exactly the same machine as it was running in your data center.
Okay.
So it's not so conceptually you are very close, but the devil is in the details, because so once you replicate and synchronize, and it's a continuous replication and synchronization. But then when you launch instances, there is a lot of transformation going on to make this runnable in the cloud side.
Sure.
And then this is the other big difference is we have a very application-centric view. Mm-hmm. So when people talk about backup, They are more around, system or host-based backup or host-based replication.
Right.
So for us, like I said, when I say my web application, I want to be able to take it from my data center and run in Microsoft Azure environment. Well, it's not just that application. It's a set of those 10 systems which made up the application have to be brought up in the Azure side.
Gotcha. Okay, that makes sense. And so, in essence, when you're talking about the operating system level things, it's the same thing as saying, well, I can get a base Linux image, for example, a Red Hat image or CentOS image or something, or in their case, they let you upload your own as an AMI or an OVF or something. What you're doing is you're saying, we move you over to this baseline thing, and then there's a process that tries to synchronize them for all the the nuances and details and so forth. But I think what you didn't say, and I think this is sort of important, you don't do something. You don't like virtualize the application. You don't do a P to V and turn it into a V app. You literally just move whatever's on that server over to a different running instance. There's not a physical to virtualization or a
Right.
you're not encapsulating things and so forth.
Well,
Okay.
really good point. So first of all, just going to add to what you said. So given the approach we've taken, we can work with both physical and virtual environments. And in virtual, we're not tied to a hypervisor vendor or virtualization vendor. This could be VMware, Hyper-V, Xen, or KVM-based virtualization. So the whole idea here is, you have an OS which is running whether on a physical machine or as a guest on top of a hypervisor. You may have some patches applied to this OS. If I were to just pick a template which comes from the cloud service provider, that's not really going to cut it. I want to be able to run the same OS which I have running in my data center and make it run with the same patches which is here, make that run in the cloud side.
Okay. Yeah, that makes sense. I understand. So I guess my next question is, and again, we'll get away from the technical stuff at some point, but I just kind of want to make sure I have an understanding of where the basic pieces work. So if I'm a customer today, I have a multi-tiered application, especially in my own data center. I have a sense of what response times are between compute and storage, or I have a sense of how I've provisioned the network to give me certain either isolation or bandwidth or whatever. How do you map something that's pretty well understood and you can kind of roughly guarantee what it looks like to a cloud environment where they're less stringent upon what an SLA looks like, or less stringent upon what storage response times look like? Is it sort of best effort, or is there a way to pseudo map those things together?
That is an excellent question, Brian. So before I get into the specifics, we also have to know the state of these cloud computing environments today. First of all, you have to remember these are not static environments; they are evolving very fast and very rapidly.
Right.
So if you look at Amazon AWS, they have this notion which is called elastic block storage, EBS volumes. Mm-hmm. They're very similar to the whole idea of you have a local disk which comes from the network, right, in your data center. Until very recently, there was this notion that the performance coming from these EBS volumes was very unpredictable, right?
Right.
Well, I forget, in the last few months, they've introduced this notion of when you go and provision EBS volumes, now you can go and say, I want this volume to have this kind of IOPS.
Okay, so sort of pre-provisioned IOPS, if you will, right?
That is correct. Provision IOPS EBS volumes. So the reason I brought this up is, if you asked me this question a year ago, I would say, Brian, unfortunately, the sad part here is we are at the mercy of the cloud service vendor until we get the same kind of performance from the infrastructure which they put in place. I could not make any guarantees. But today, that especially for I/O, things are changing. So in case of AWS, we could go and make use of provision IOPS to kind of bring performance close to the performance characteristics which you had in the data center, right? When you talk about other clouds, they are behind in this regard, but I wouldn't be surprised within the next 6 to 9 months you would see similar capabilities from the other cloud vendors too, right?
Okay.
And when it comes to networking, so let me just finish the IO side. So we talked about the disk side, then on the networking side, again, part of our technology, and we didn't talk about this. What we've encountered in some customer sites is that they have notion of the IP address embedded inside the database, even though they shouldn't. But sometimes it's relatively easier to write an application where you may want to store the IP address in the database.
Sure.
Well, if I bring up the application, and when again application means the entire suite of those 10 systems with the same OS, the same config, the same app data. Well, we go on to the extent of making sure we preserve those IP addresses so that when the application comes up and runs in the cloud side, it still thinks it's running in the data center because it's the same IP addresses.
Okay.
So again, these are and these things have become possible because you're hearing a lot of talk about network virtualization and SDN because a lot of these elements are now getting embedded in the cloud service providers infrastructure, which we as a vendor, CloudVelocity, can take advantage of and offer services to the enterprise.
Okay, I got you. So to a certain extent, while there's a number, so AWS, there's characteristics that AWS and say Rackspace and Azure have in common. There's still some differences in the services they provide, and you guys have enough intelligence across a number of clouds that you can sort of go. This one provides certain additional network services. This one provides some other set of services, and you can kind of help guide customers to the right match for what their applications need.
You got that.
Okay.
Absolutely. And in fact, we are talking about potentially building an assessment tool where we could try to also automate that process instead of being involved with the customer so they could actually run the tool and get an early feel for what's possible and what's not possible.
Okay. So as you're going to market, right? We talked about early on about sort of the problem customers have. They'd like the idea of infinite resources. They can't typically fund that or budget for that internally. What's a typical conversation you're having with customers, not just about the technology, but kind of helping them get over the hump of saying like, hey, you can trust these external clouds, or we can be sure that they're going to run the same way. What's that conversation look like today?
Well, so again, it really depends on the size of the customer. So the conversation is a little different on the mid-market versus large enterprises,
Sure.
right? So what we have seen in large enterprises is there's the first desire is they want to be able to make room in their data center because the case to build new data center is just not there. So they are looking to see, well, if there are some applications which are running inside this data center, can I just take them off my data center and run them somewhere else, like in a cloud side? Mm-hmm. So I can make room and run some applications which require access to more sensitive data, which the enterprise is still not comfortable putting in the cloud side, right? Okay. So the conversation starts with a migration of their existing workload from their data center to a cloud side, leading to, hey, you know what? So once you play with our software, you get more, confidence in what can be done, and you see this now new world of infinite resources, which is just available at your fingertip. So essentially, instead of buying that next server, the value proposition becomes that next server comes from the cloud side, and that server can be used for the dev test or anything else, because it looks. Remember, the one part which we talked about is when we get these resources in the cloud side, they still are able to use services like the AD or LDAP, which reside back in the enterprise.
Gotcha.
So the control and security is still with the enterprise IT, while you've gotten the agility what the cloud offers you.
Okay. Now, for customers that you're working with, whether they're doing this in production or they're doing it sort of in beta and proof of concepts, what's their world look like after they've been through sort of your migration? Where are they managing the applications and resources from? Which tools are they using? Are they now using your tools? Are they still using VMware vCenter, or is it? What is their new sort of management view of the world look like?
Sure. So first of all, if you look at our customers, and I'll just talk about one specific customer, Lialta Media. So they are using our software to use AWS as their secondary data center. So they have a web application which is running in a colo, and they have used our software to essentially provide 24/7 availability of their web application in AWS. In case of an outage, they can fit over there.
Okay.
So their management environment is exactly the same what they had for their existing colo-based environment. No changes there. But when the failover happens, then they use our tools and our software to manage the instances which come up in AWS. And the beauty of the solution for this customer was, okay, so before I say that, when you look at these cloud environments, there is the compute, storage, networking, and security models are very different than what you are used to inside the enterprise.
Right.
We talked about EBS resources. We talked about provision IOPS. Well, we happen to, Brian, be in the industry, and we're keeping track of what's happening. If you're in the enterprise looking at traditional enterprise IT environments, this is not how the enterprise IT looks at storage. This is not how enterprise IT understands networking, the notion of VPCs. So what our software does is essentially removes any learning involved in all these cloud environments. And behind the scenes, all these processes are automated. So we become the management station for the instances which come up in the cloud side. Down the road, so we expect, for example, like for Microsoft Azure, we do think there might be value for us to think about writing a plugin for System Center. So if you had Windows-based workload which you were managing using System Center inside the enterprise, the same System Center now could manage this workload inside the cloud side. But that's the roadmap. That's not there today.
Sure.
Let me just clear.
Gotcha. And do you see? I mean, like it sort of dawns on me, and maybe this is a use case, or maybe it's not. I mean, it feels like you could help people, move existing workloads for, capacity management or for cost or whatever. But it also feels like it's almost like a first step would often be for people to use this as a way to build a backup system for them or disaster recovery. I mean, do you see that more so, or do you see them jumping in with production applications first?
Well, so we see a mix. Mm-hmm. So in mid-market, we actually see cloud-based DR just standing on its own. There's no discussion about migration of their workload. It's about the mid-market customers could not afford to build a secondary data center or work with the very expensive professional services vendors where they offer you DR. So what we've done is essentially enable them to use the cloud, the public clouds like the Amazon or Rackspace or Azure as their secondary data center for DR purposes. But for the very large enterprises, typically they've already spent the money for their tier 1 apps and protected them. So again, when we say DR, I'm not just talking about data protection. This is 24/7 availability, so the application still continues to run. So the large enterprises have already spent the money for their tier 1 apps, and they haven't done that for their tier 2 and tier 3 apps because it's a very expensive value proposition, right? So what we bring to the table for these large enterprises is cloud-based DR for the second and third tier apps today, but the conversation starts with migration. There's some element of the dev test use case where your existing apps, you could clone them in AWS or Azure and use that as your lab, grow and shrink your lab as and when you need. And the third use case is cloud-based DR.
Gotcha. That makes a lot of sense. Well, listen, we're sort of getting towards running out of time a little bit. So real quick, I guess like you talked about. I mean, you've been in startups before. You've been in the investment VC side of the world. You're now back doing startups again. I mean, where do you see sort of this evolution of hybrid cloud, or even just the evolution of how people are gonna leverage resources, whether they're in-house or out? I mean, like, what are the big drivers you're seeing, or the big trends that really are pushing you guys to keep moving forward?
First of all, I just want to clear, I was not on I was at the VC, but as an EIR,
But you've seen that side. You've seen that side of the fence where you're looking to make bets on where things. Yeah, absolutely.
So, we believe hybrid cloud is the future, and it's so promising that you want to be able to think about the next era of computing is going to be about being able to leverage your own resources and resources which you rent. So you have to be able to figure out, first of all, I don't believe everything is going to move to the cloud. Of course, the cloud service providers would want you to believe that your on-premise computing is dead. At least I don't believe that. There is going to be on-premise computing for the right reasons, and there is going to be lots of these public clouds available. So the long run, you have to be able to think about this, that these resources form a dynamic pool, and based on different characteristics, whether it's cost, performance, or any other criteria that you run your workload, or security, you run your workload in the environment which deems fit for the application.
Gotcha. Yeah, no, and I would agree with that. And I think, again, like we talked about at the beginning, there's been so many people that want this sort of best of both worlds. They want to be able to leverage the flexibility and costs of public, and they want, they've got, like you said, they've got investments they've got to maintain and skills they want to maintain. I think that makes absolute sense. And the interesting thing becomes, can you figure out the right technology to make these things happen fairly seamlessly? And like you said, people don't have to learn all the nuances of the new public cloud or some new tool. So that's very, very cool. I appreciate the time tonight. Thank you very much for being on. So for people that are interested, they want to learn more about CloudVelocity or come and talk to you, where can they expect to see you, out at events, for the next couple of months at shows, or what's the best place to learn more about CloudVelocity?
Well, these days the best place is online, so come and see us on our website, www.cloudvelocity.com. And there's a lot of information on the website, as well as if you want to try out our service, just sign up on our site, and you'll be able to try out the service as well.
Okay, very, very cool. Well, listen, folks, so Rajeev, thank you so much for being a guest on tonight. Aaron will be back with us next week, everybody. So as always, folks, if you like the show, tell a friend, or please leave us a review on iTunes. You can follow us on Twitter at thecloudcast.net, or obviously on the web at thecloudcast.net. So for Rajeev and for Aaron, thanks to everybody for listening tonight, and have a great night.